Welcome to The Architecture of Change, a blueprint for understanding chemical reactions and equations. Matter is always transforming and follows a set of rules. Chemical changes are everywhere, like rust forming or food cooking. A chemical reaction fundamentally changes a substance, often shown by a change in color, temperature, gas evolution, or state. The foundation of chemistry is the law of conservation of mass. Mass is neither created nor destroyed. The total mass of reactants must equal the total mass of products. Atomically, the number of atoms for each element must remain exactly the same. Chemical equations are the elegant language or blueprint of chemical change. We move from long sentence descriptions to concise word equations, and finally, to skeletal equations using chemical formulas like Mg plus O2 right, pointing arrow magnesium oxide. However, a skeletal equation may contain a flaw. For example, Mg plus O2 right pointing arrow, MgO, violates the law of conservation of mass because the atoms are not equal on both sides. This blueprint is incomplete and must be balanced. To construct a balanced equation, we tally the atoms and add coefficients until the number of atoms for each element is equal on the reactant and product sides. This ensures mass is conserved. To enhance the blueprint, we add critical details. Physical state symbols like S for solid or L for liquid indicate the state of each substance. Reaction conditions, such as sunlight or a catalyst, are written above or below the reaction arrow. Structural pattern 1 is the combination reaction, where two or more reactants form a single product. The formation of slaked lime is an example, which is also an exothermic reaction, releasing heat. Structural pattern 2 is the decomposition reaction, the opposite of combination. A single compound breaks down into two or more simpler substances. These are often endothermic reactions, requiring energy in the form of heat, light, or electricity. Structural pattern 3 is the displacement reaction. A more reactive element, like iron, displaces a less reactive element, such as copper, from its compound. This is observed as the iron nail changing color and the solution fading. Structural pattern 4 is the double displacement reaction. This involves an exchange of ions between two compounds. A common result is the formation of an insoluble white substance, called a precipitate. The engine of change involves oxidation and reduction, known as redox reactions. Oxidation is the gain of oxygen or loss of hydrogen. Reduction is the loss of oxygen or gain of hydrogen. These transfers are fundamental to chemical change. We see the real-world effects of oxidation in corrosion, like rusting iron, and rancidity, which is the spoilage of food due to fat oxidation. Rancidity can be prevented by adding antioxidants or using nitrogen flushing in packaging. This video has outlined the chemist's architectural toolkit, the foundation of the law of conservation of mass, the blueprint of the balanced chemical equation, 4 structural patterns, and the driving process of redox reactions. Chemical reactions are an elegant, rule-based system. From a simple blueprint to the vast universe, these fundamental principles govern the constant transformation of matter that shapes our world.